Okay, hello, welcome back to another one of my video log recording sessions where I talk about genetic algorithms. The date is, well, the date time, here we go, 2025, June 27th. The time is 2:07 a.m. And it's been about 4 to 5 days since the last video, and I've been experimenting with some ideas, and before I move on to, well, let me rephrase that. Okay, so I have been experimenting with a couple of ideas on how to do chaotic genetic algorithms, as I stated before, and yeah, so that's what's been taking up most of my time, researching ways to implement or apply the idea of chaotic genetic algorithms, the chaotic way of doing it. But before that, I felt that I needed to, in a way, amass what I have been doing, because since the last video was also kind of about that. So amass what I have been doing and run a bunch of evolutions, well, iterations, and as a culmination, as some kind of a culmination of everything I have learnt, found out so far. Well, most of it, except the part where the genes or items become nons or something like that. The gradual increasing and decreasing stuff. So that part is especially more complicated. It's not hard, it's just hard to keep track of everything or not. But I'm sure that I need to come back to it pretty soon. Because I think there are, with a bit of an exaggeration, a million ways of doing this, and I've only merely scratched the surface. So I'll come back to this part, nons, where I also deal with nons, where some genes sometimes disappear and appear in one era and then reappear or redisappear in the next, or so. So barring that, I have ran a bunch of evolution iterations. To be exact, 36 of them. I know that's a lot. And the reason why there are so many is that I originally intended to do just one or two, and then that became 4. The 1 or 2 was where I would just collect all the ideas that I have done and just run it a couple of times. And then I thought, why not also just run the evolutions with and without, or with or without the void chromosomes or void entities and random entities per generation. So that's 2 categories added, and they're either on or off. So let me get the paint. So supposing that I had everything, well, almost everything, almost everything, and then I wanted to run 1 or 2 times, see, once or twice, and then I thought, let me also add the option to enable the creation of void entities, and also the option to enable the creation of random entities. So this is either on or off, and this is either on or off. And this is where it was proper tail. That's too big. That's too big. That's still too big. This was with proper tail for the learn method, and the XP tail for the candidate method, and then the candidate percentage would be, well, 0.2 as always. So and also the procreate function that I wanted to use originally was random, as I've always used, the one that I've always used, random selection procreate, where the 2 parents are just selected at random, because I like this idea better than the favoring highs, although I'll have to admit that it was an abrupt change. So this is what I wanted to do, and then I added these 2 options, so that's 4 more, so that's at least 4 iterations, 4 runs. And then while I was doing that, I thought, why not just run all the other possible, easily applicable procreate functions, and there are 7 more procreate functions that I could just use without much modification. Proc fx, so that's 8 procreate functions times 4 possibilities, 4 possible settings for these options, for void and random entities, for the creations of void or and random entities. So that's at least 32. And I thought, well, that's a bit extreme, isn't it? Because I always complained that I was just doing this too many times, for too many times, and it would all just, well, have me record for more than 40, 50, or 60 or 70 minutes. So I thought that was a bit, overkill or extreme, but since I was also collecting all the possible unique true ceilings for true ceilings, where the true ceiling, where the summed utility value of the true ceiling is 2865. This is, of course, with the lower maximum constraint values, with preset 100 items. So since I was kind of, well, I was collecting this, because originally there were about 100, and spoilers, now I have 300 and how many? 378, which is still very little, because it's 2 to the power of 100, So that's 378 out of 2 to the power of 100. So that's still very, very a minute portion. But anyway, it went from 100 to 378 so far, and not all of the additional ones were from these 32 runs, since I've been doing the prototype of chaotic genetic algorithm. But yeah, the point is that I did the 32 runs because I, for the sake of collecting more true ceilings. And I'm just going to have a look at the some of the distributions or whatever. I should really stop saying whatever. It's not whatever. I'm doing this. This matters. I shouldn't say whatever. But whatever. Anyway, stop saying anyway. So, moving on. But before we have a look at the distributions, the summed utility plots from all the new 32 runs, I think we should look at this one first. And this is kind of like a list. Well, originally it was a dictionary, but let's just call it a list. It's a list of how many unique true ceilings were found during each run, with the name of these date times. So up here you can see that the vanilla, this is where most of the fancier options were just omitted or left out, and everything was vanilla. So like it probably had, let me go back and look at it. It wasn't even dynamic anyway. It probably was not even dynamic. Just 100 items, 1000 entities for 1000 generations. And while I did that, I had 39 unique true ceilings. And for example, with this setting, this is when I was doing things the dynamic way. With this setting, I had 46 unique true ceilings. But this does not mean that the 46 unique true ceilings are completely unique or completely different from the 39 unique true ceilings from this run. Or they're not entirely different. It's not guaranteed that these unique true ceilings, whenever they were found, were totally different from the other runs. And when I do this, in the end, they're all consolidated into one list, and then I would also use the code in Python to get the set of the list, and count how many unique true ceilings 2865 are. True ceiling 2865 there are. So, and so far there are, and I should just add this manually by hand. Sorry about the noise. And right now there are 378 true ceilings. That's including all these runs named, all these runs with the prefix of chaos. These are the experiments that I have been doing for for the past 2 to 3 days. But before that, today's video, I'm just going to cover these runs where they all start with the prefix that is cul underscore, cul as in culmination, and it starts here actually. I messed it up a bit, so I'm just gonna copy this and just sort them in order. What did I do? I started from -1, then 0, and then 4 should go here. So that's about it. So now it's in incremental order from -1 to all the way to 34. Now, the first 4, starting from 1 to 4, as in here. Okay, let's just say this -1, I used random selection procreate. And the same for 0, just as a test. And from usually 4 runs would share, or rather would be using the same procreate function. So the first 4, starting from +1, starting from number 1 all the way to 2, 3, and 4, would be using the same procreate function, and in this case that's random selection procreate. And there are 4 runs, because this one would be, for this one, for the first one, the void option will be turned off and the random option will also be turned off. For the second one, the let me just check if I have it right. For the second one, the void option will be on and the random option will be off. The third option, the void option, will be off. You get where I'm going with this, and the random option will be on. And lastly, but not least, the void option will be on and the random option will be on. So that's why there are 4 runs per procreate function. So in one of my videos I said that when the procreate function favors, when a procreate function favors, let me rephrase that, in a run, in an iteration, evolution iteration, if the procreate function that is being used favors entities with high or relatively high some utility values, I showed that the distribution of entities would be very skewed, and not to mention that they wouldn't necessarily guarantee convergence, as in they wouldn't really, just because a procreate function really favors high sum utility value entities, doesn't mean that iteration would produce numerous true ceilings, and that is still true. But it seems that when I used the random selection, I've only had a handful. It's not even a handful. It's out of 7 runs, I only have 3. So, and I have 5 fingers on my hand, on any one of my hands rather. So it's still less than 5. So it's not even a handful. The second one I used, the second one that I used was, of course, where is it? Come on. The second, for the second 4 iterations, I used the probably the Lonely Island procreate function. Yeah, lonely procreate. And let me just write that, lonely procreate, and the first 7. No, go away. No, why did I? Yeah, so that's good. Random selection, lonely procreate. The third one I used Monopoly Elite, Mono Elite, and then it was Mono All, and then it was Oligopoly, and then it was Favoring High, and then after that it was proportional. I know I sometimes write proportionate, and then here I'm writing proportional, so I don't know why I do that. And then the last one is less Fave High. And then what's the third? What's the last two? I don't know. I have to find out. I'll find that out right now. Oh, it's random selection again. Random selection. So that's what I did, and the order of the settings are the same. It's always void off, rand off, and then void on, rand off, void off, rand on, and then void on and rand on. Rand as in random. So I try this, and then what's interesting is that if the procreate function in question really favors entities with high sum utility scores, for example the lonely procreate, that does not mean it does not guarantee numerous true ceilings. For example, this one really favors really favors that one top entity with the highest sum utility value, and it still only managed to produce 6 in this run, 0 in both runs, and then only 1. And then when we use the Monopoly Elite, as in the top entity gets to procreate, top entity is parent 1 and parent 2 is chosen from the top 10%. I only had 15 and 10 here, so that's not really a lot. In my opinion, I don't think that's a lot. Monopoly All, where parent 1 is the top entity and parent 2 is could be any one of the entities within the world in that generation. It only created 2 entities, so that's kind of, okay, it seems obvious, no? I don't know. And then oligopoly, I once said that I also had something for oligopoly procreate function, because I thought that this one performed quite, this one gave quite a robust performance when I was just doing the more than vanilla way of generating algorithms. But even this only produced 17 in total, and favoring high, none. Proportional, 4. See, this is the problem. Favoring high literally favors high sum utility score entities. Proportional doesn't. It favors, yes, but a bit less. It's in proportion to the total sum of utility to the total sum of all summed utility values in that generation, within that generation in the world. And it managed to produce 4 true ceilings, whereas favoring high, none here. Less favoring high, 6. See, here's the problem. Favoring high, none. Less favoring high, 6. And random selection, 0 again. So then, okay, let's go have a look at this one, 22, 1. There we go. You probably that's too full screened. You probably can't see any line here because they all kind of converge quite extremely per era. Even here, look at this. This is so high that it doesn't really like register in your eyes. In the 5th era, in the 8th era it's a bit different. In the 9th era, this is what it looks like, and in the 10th era, at the end of the last era, this is what it looks like. And there was a true ceiling entity here, but yeah, compare this to the one with the most true ceilings, at least in the Culmination series, 15, 22-9. Compare that to this. So we have this where it really converged. If you look, the true ceiling is the mode, or the mode is the true ceiling, and there are 262 entities here. And usually, when when an entity has hit the true ceiling, so when an entity has hit the true ceiling, its mutation rate, its individual mutation rate is 0%, so it will just stay there. So that's why entities are stacking up here. Once they reach this point, they'll just stay there, kind of. Very likely to stay here. And number 9 was we're using Monopoly Elite. So the top entity, whichever entity that has the true ceiling sum utility value, always gets to procreate. So the supposedly good gene, it's not good, spoiler alert, but the what seems to be the best in that generation gets to be passed on to the next generation. So that's why this is happening. If you look here, the convergence is a lot less, well, apparent. But like I've said like a few thousand times by now, I like this better than this. Yeah, look at that. Look. This portion, the left portion, is so small because all the entities, well, not all, but 262 entities are stacked up right here at the true ceiling. Whereas here, it's not so much. The true ceiling is only this bit, and that is around 2 or 1 or 2. I think 1 probably. But I don't know, I prefer this. But that doesn't change the fact that random selection procreate in these 7 runs albeit with different settings for the void and rand enabled options. They have failed to produce numerous true ceilings, but I think that's okay so far. Let's have a look at another one. Oligopoly 17. Look at that. Look at this high convergence. Almost 260 here. But here's the thing. I just need some water. There are 260 entities here at the true ceiling mark. Entities that have actually hit the true ceiling, and when I use the Monopoly Elite, there are 262. Is it Monopoly Elite? Yeah, there are 162 entities. But if we come back to the number of unique true ceilings, it's only 15 out of 262, and with in the case of oligopoly, it's only 8 out of 262, and here it's out of 260. I mean, just looking at the last, just looking at the end of the last era, I'm sure there are more. I'm sure there are more because I've actually done it. I've actually counted them. Of course, with code, not with my eyes. But anyway, by using the code that I wrote. But anyway, the point is, the number of entities that have hit the true ceiling or true ceilings can be high, but it does not necessarily mean that the diversity of true ceilings is guaranteed, even in that case. Even when a true ceiling or 2 or 3 have happened. That's because the mutation rate is almost 0, and no items or no genes change, and they just stay there, which is bad news for diversity or robustness of the population. I'm always trying to aim for robustness or diversity, along with the very existence of true ceilings, because like I've said a million times in my video logs, things will change, conditions will change, and when they do, a lot of entities will fail, and the population will suffer, even a greater deal than when, say, a population had the population be more, slightly more diverse, in a good way, not in a bad way. I mean, being diverse has a lot of meanings. Like, I think I've drawn this a lot of times. If the population looks like this, it's diverse. If the population looks like this, it's diverse but less diverse. If a population looks like this, this is also diverse. If a population looks like almost like a uniform distribution, this is also very diverse, probably the most diverse. But is this robust? Like, then you might say define robust. Well, but I think regardless of the definition of the term robust that I'm using, in whatever sense I'm using this, I don't think you would actually want, I don't think anyone would actually want a entity distribution that looks like a uniform distribution. So something like that or that is what I'm looking for. So in that sense, coming back to the number of unique true ceilings, and this isn't so great either. Let's have a look at 20. Oops. And you'll see this is very diverse, because both the random entities and void entities have been enabled, so that's why these entities exist right here, very low in some utility values, but somehow, well, not somehow, but still quite a few entities have managed to hit the true ceiling at the 165 mark. So there are 165 entities at the end of the iteration that have hit the true ceiling 2865. But how many unique true ceilings? 9, or less than 9 at this moment, equal to or less than 9 unique true ceilings. This is the number of all unique true ceilings throughout the iteration, so that's why I say equal to or less than 9. Same here, equal to or less than 15 out of 262. So, and there were a few other iterations that I had done, and it really depended, but what I learned from the iterations that are not covered here, and during all the other iterations that I have done so far, was that it really depends on luck. On luck, or let me rephrase that. Luck plays a crucial part in whether a run or an iteration ends up with 1 or 2 or maybe even like something like 37 or 46 unique true ceilings. Because if the path is set where it is very unlikely that entities will hit the true ceiling because of the way the evolution scheme is set up, true ceilings won't happen, probably. If the path to true ceiling is actually set, and that's where the entire evolution iteration is going, yeah, then there will be entities that have hit that, or there will be entities that will hit the true ceiling, but that still doesn't guarantee the diversity of unique true ceilings. Which, and then I saw, I went back and then I had a look at why these 3 numbers happened: 46, 32 and 34. And this is when so that's 6, 10, 3, 4, 5. This is when things were dynamic. So for example 3 for this one, this is where the constraint values were dynamic, were varying, and yeah, only the constraint values were varying. But granted, because the number of items was fixed, is fixed from the start, because of that, entities had more time, as in more generations, the 1000 entities that it got to start with. Or I mean, they all start with a population of 10 entities, but very soon enough there will be 1000 entities in this case. So for 1000 generations, 1000 gens, this iteration actually gave the entities a lot of time and a lot of room and space, a lot of opportunities for them to converge, to hit the true ceilings. That's why there were so many unique true ceilings. Same with 4. Same with 4. And with 5, yeah, almost the same with 5 as well. But here in this case, both the util vals, right? Yeah, util vals and constraint vals were varying, but the entities still had a lot of time to evolve and converge. And of course that took a lot of time as well, because it was just 1000 population. It was just population 1000 from generation 1 or 2, and then until generation 1000, until the last generation. So this took a lot of time, so it's very computationally intensive. But what about number 2? Well, this is kind of similar, where the utility values were varying. So the utility values were changing, according to some form of a normal distribution, and the constraint values were fixed, and the number of items was fixed. So something like that. But again, this one had a lot of time. But 0, 1 and 2 had the same settings, I think. Hold on. No, 1 and 2 had the same settings, and this one only created 4, provided us with only 4 unique true ceilings. So again, a lot of luck is needed to guarantee a numerous or a wide variety of true ceilings. But if luck isn't happening, then what I said about what I said about the path being set, because if this is the start, and because mutation is very random, there will be almost an infinite number of paths, and some will lead to true ceilings, others not so much. So what should I do if an iteration has started and it's quite likely that whatever you do, the paths that lead to no true ceilings exist more in number compared to the paths that do lead to true ceilings. That is, if we stick to that path. But if we come back here, the act of having the utility values or constraint values vary or change to some distribution, to some type of a distribution, that likely changes the path, or can change the path, and we might be able to get true ceilings. I mean, maybe not, but maybe yes. So, and that is why, well, I forgot a part there. So so we need a way to also ensure that if this was a movie about time travel, we need a way to ensure that the timelines are not actually kept intact. We need to make sure that timelines get entangled, that we may be able to visit all these possible timelines, and in that process collect all the true ceilings that may exist or can exist. I think one of the ways of doing that is having dynamic values, and like I said, dynamic values, or having a dynamic setting, not to be confused with dynamic programming. That's one way, and we've done that. And the second way of doing it is chaotic. The chaotic way of doing this. And a little bit of a preview, a sneak peek into the next video, into what the next video log will be about. This is what happens if I adopt the idea of chaos. So I do seem to be getting more unique true ceilings, but this is still just an idea that is in development. So, but I think the idea of intertwining, just entangling all these possible timelines or these paths, so that we revisit all the true ceilings that can exist or that may have existed, like here, right? Like here, or that could exist somewhere in the future. Just visit all of these paths so that we collect all the true ceilings. And this is the purpose of this, or the reason why this may work, is that like I've said, if an entity has hit the true ceiling, then the mutation rate, if an entity has hit the true ceiling, its individual mutation rate will be 0 or very close to 0, so it will be able to stay that way for the foreseeable future, as long as the conditions don't change. But yeah, that's what I'm doing right now. So yeah, I'm trying to work on a way to do chaotic genetic algorithm. So far, all these runs that I've done, starting from yesterday or the day before yesterday, 39 runs plus 3, so 42. But I must confess that they're not 100% chaotic. not in the way that I imagined. So there's something like semi-chaotic or quasi-chaotic. Yeah, but trying to build a prototype. So I didn't think it was going to be easy, so it is not easy. Okay, that's about it for today. Thanks for watching. Okay, bye.